You know, there are these incredible, invisible systems all around us that keep things running smoothly. And today we're going to pull back the curtain on one of the most important ones you've probably never heard of. It's the universal language that lets a police department in Miami instantly check a fingerprint against a massive FBI database hundreds of miles away. We're talking about the standard that connects thousands of law enforcement agencies, making sure a crucial match is found not in days but in mere seconds.
I mean, really think about that for a second. A local cop in California scans a fingerprint. How does that digital file travel to an FBI database in West Virginia, get searched against literally millions of records, and then send a response back, all before the officer has even finished their paperwork? So how on earth does that happen? Well, that's the puzzle we're solving today, and the key is a ridiculously powerful standard called the EBTS.
All right, so here's our game plan. First, we're going to look at the universal problem they were trying to solve, getting all these different systems to just talk to each other. Then, we'll define exactly what the EBTS is. After that, we'll break down the core things it lets you do, follow a single fingerprint on its high-tech journey, and finally, we'll talk about why this standard really, truly matters.
So before a standard like this existed, it was chaos. Just imagine thousands of different agencies, all with their own homegrown computer systems, trying to share critical data. It was basically the digital version of everyone speaking a different language. And that led to huge delays, lost information, and, missed chances to solve crimes or verify who someone was fast. They absolutely had to find a common language.
A great way to think about it is like a universal postal service, but for biometric data. And what's so cool about this is it's not just about sending a package from point A to point B. I mean, for a postal service to work, you need a standardized address format, right? A zip code, clear instructions on the box. The EBTS does exactly that. It makes sure the package, whether it's a fingerprint, a face scan, whatever, is perfectly formatted so the system on the other end knows exactly what it is and what to do with it. Instantly, no confusion.
So, we get the problem. Total digital chaos. Now let's get into the elegant solution that finally brought some order to it all.
Okay, this is the official rulebook. The Electronic Biometric Transmission Specification, or EBTS for short. It's the FBI's definitive guide. It lays out exactly how biometric data has to be encoded and sent to talk to their main database, which is called the Next Generation Identification, or NGI system. It's really the technical handshake that makes everything else work.
And this isn't just about fingerprints anymore, not by a long shot. The standard covers a ton of ground. Of course, it has the classic 10 prints and latent prints you see in crime shows, but it's grown to include palm prints, facial photos, pictures of scars, marks, and tattoos, and even really high-tech stuff like iris scans. It's a living standard, designed to keep up with technology.
So once you have this universal language in place, what can you actually do with it? Well, the EBTS isn't just some boring file format, it's the key that unlocks a whole suite of powerful services that agencies use every single day.
These 6 services are pretty much the action verbs of the whole system. An agency can ask, who is this person? That's identification. Or, is this person really who they say they are? That's verification. They can pull a criminal history, the information service, or search a print from a crime scene against old unsolved cases. That's investigation. And the last 2, notification and data management, are super powerful. They send out automatic updates and help keep this gigantic database clean and accurate.
Let me give you a powerful real-world example of that notification service. It's called Rapback. So imagine a school runs a background check on a new teacher, and they come up clean. Well, with Rapback, that's not just a one-and-done thing. If that teacher gets arrested for something anywhere in the country, after they've been hired, the system automatically sends an alert back to the school. See how powerful that is? It creates an ongoing safety net.
To really get a feel for how this all works, let's follow a single piece of evidence from the moment it's found at a crime scene all the way to the FBI and back. So picture this. An investigator has just lifted a single, clear, but totally unidentified fingerprint from a crime scene. This is what they call a latent print. And right now, the clock is ticking to find out who it belongs to.
Okay, here's what happens next. First, the local agency packages that print into a specific latent fingerprint image search transaction and fires it off. Step 2, the FBI system gets it and instantly starts searching against millions and millions of records. 3, it shoots back a list of possible candidates for a human expert to review. But here's the kicker. This is the really cool part. If there's no match, that print isn't just thrown away, it gets stored.
And if, maybe years from now, someone gets arrested and their prints match that old cold case, boom, the system automatically sends a notification back to the original agency. The system never, ever forgets.
So let's zoom back out. We've seen all the technical details, but what's the actual real-world impact of a standard like EBTS? Why is this so much more than just a tech document?
I mean, this slide really says it all. We went from a world of literally mailing physical fingerprint cards to instant digital transmission. We went from systems that couldn't talk to each other to full interoperability. We went from slow manual searches to automated ones that give you results not in weeks, but in minutes or even seconds. The leap forward here is it's staggering.
And just to put some real numbers on that speed, the standard itself actually sets goals for response times. For an iris ID check, the goal is 10 seconds. A standard 10-print search for a rap sheet, 2 minutes. And even for a super complex latent print search against the entire database, the target is just 2 hours. That's the kind of speed that can absolutely change the course of an investigation.
So at the end of the day, this isn't just about cops and robbers. This system really impacts all of us. It means faster public safety because suspects can be identified in a flash. It's the engine behind the trusted, fast background checks that protect kids in schools and other vulnerable people. It's a huge piece of our national security. And because of the strict rules for data quality, we know the system is built on a foundation of reliability.
And that brings us to our final thought for today. The EBTS has been this incredible success story, right? It brought order from chaos, and it's enabled technology that was pure science fiction just a generation ago. But as biometrics get woven even deeper into our lives, the challenge changes. The big question for the future is this: how does a powerful standard like this keep adapting? How does it embrace new technologies to keep us safe while also, and this is key, protecting our fundamental right to privacy? It's a tough balance to strike. Thanks for tuning in.